chapter 51, 70, 10. So those are the chapter which I will be working with you slowly. This is very important because we are looking at the actual document which will be used in your career, your future career. If you're working for the airlines as a technical services or working for MRO as technical services engineer, so these are the activity, these are the manual that you will be referring to. So I'm guiding you to look at this manual and how we can use this manual to guide you to develop the repair for the defect found on the aircraft. If you got any question, please stop me. So I'm showing the Jamboard here. Before that, let me show you the manual. I will walk through with you on the manual. Okay, so here I do not want to go through from page 1 because I think I have shown you. So we go straight to where we are, where there are they call it concept repair, example repair. So we have 11 of these for several scenarios. Because like I said again, the aircraft structure, characteristic features or designs, aircraft structure design concept are always having skin and angles, extrusions or form. Extrusion is something that you get from the factory. Form, I mean something that you order already a completed section, either U or I or Z or T. And for the form is something you bend, something you form yourself. If it's been done for the manufacturing of aircraft, it has been done in a factory. However, it's not something easily available. It's not something readily sell. That shape is not easily sell. It's form. It's the second is from the sheet metal form into the angle shapes. And normally for large aircraft, we use all extrusion. And for smaller aircraft, we do see this kind of form section because easier to form, and also the thickness is thinner than the extrusion. Large aircraft, higher load, so they need to carry the load across, and they need to have more thicker and more stable section. So that's why we use a lot of extrusion. Okay, here let's look at, I just review one by one of the example, and then we go to detail one of these. So you look at here, this is an angle, this is skin, and we have this form angle L, and happen to be this vertical flange, horizontal flange. So all the legs here, all the portion here for extrusion, for the angles, doesn't matter what kind of angle, U, I, H. So this portion that hang out here, we call it flange. So anything that hang out in English, sometimes, and most of it, we call it flange. So this is a flange. So this is a vertical flange, this is horizontal flange. And for this angle, the horizontal flange has been damaged. So like everything else, all the repair, if you got damaged section, damaged part, you cut them off, remove. So remove this horizontal flange section and you install a filler, which is similar material, similar thickness, to fill up the space and you design a L angle doubler to put over those area, damage area, and you put the rivets. We put 3 rivets across. We count here. We're not counting on the damage area. We have 3 rivets across the cut. So this is one. So we have form angle and skin, damage horizontal flange, remove the damage, install a filler to fill up the space, and install doubler. If you notice later on, all this filler is only required when you have damage on the horizontal flange and we have a doubler to cover it. Because if you imagine, if you do not have this filler, if you leave those area blank, any kind of water, moisture, dirt will go into the area. So we do not want things like water or moisture because those are the catalysts for the corrosion. Those material are electrolyte, which can which can start the electrolysis process, and that is how corrosion has occurred. And then the next example 1. If you look at example number 2, so this example number 2, this example number 2, this is skin, and there is a extrusion cutout. In this case, the vertical flange has been damaged, so the area has been removed, and they install the doubler over the area. And we don't put filler in the area because there's open area. Nothing will go and sit in there because it's an open area. Unlike the one that we have earlier, is sitting underneath the doubler where the moisture water can trap inside there. So this is example number 2. Example number 3. Example number 3 is a exclusion complete cut. So this is exclusion skin. You cut off the whole section. You install a filler, and then you install doubler. You can see here, they only install underneath the doubler. They don't bother about installing the filler on the vertical flange side. So again, that's what I was telling you, because we do not want anything to strap inside there if we do not have the filler. That's why we have to install the filler underneath the doubler for where the cut is. And then you can see example number 4. Example number 4 is profile. Profile means this section here is form and the skin. It's not a straightforward form. It has a profile because it's a curvature over the vertical flange, and there's a normal horizontal flange. However, this is form. Then what you need to do, if you have damaged the vertical flange, remove them and put a doubler over it, following the profile. Then example number 5. Example number 5. Here is a profile complete cut. And like we have seen in the exclusion earlier, you remove the whole thing, and the area underneath the doubler, we install filler. Again, for the similar purpose, we do not want anything trapped inside that area. Example number 6 is T profile, is a T, inverse T, and we have damage on the section. So the section has been removed and then install doubler on both sides and with the filler. Example number 7. Example number 7 is a C-beam upper flange cutout. So this is C-beam because it's look like C, and we have damaged the vertical section, and then they remove the section and install another section of C over the damage. Then we go into example number 8. Internet is a bit slow. Example number 8, we have typical form section cutout. So number 8, we have skin and we have form C channel, and you can see they cut it out, remove the section, install the section filler, and install the doubler. And this doubler is an L and intermesh into another L. Why? Because we are not able to really get a good C channel form. So the easiest way to adjust is to make two L and put them together to form the C. Then example number 9, we have section cut. It is almost similar to what we have in the previous example 8. However, this doubler is intermeshed at outside. So it's depending on the complexity of the area that you are repairing. So you have two options, whether you put the L inside or you have one outside and one inside. The most important thing is the load carrying capability of this section has been restored because repair is restoring. However, if you do not have a proper loading condition, or you have misalignment in the load, and then you have increased the stress in the area. That's why we have to be balanced. Load transfer across this section should be balanced, or else we have unnecessary stress. And then we have example number 10. Number 10 will be I-beam, upper flange cutout. This is a strong beam, I-beam. Upper flange cutout, you cut out the upper flange and you do have L angle both sides to form the T, because this is a T sections. Then the last one will be, is it the last one? example number 11, where we call this here is web repair, limited cutout height. So this web repair, we have spar web, we have wing web, we have many webs. We have all the control surfaces with webs because we have spar and we have webs. So that is kind of typical construction. So for the short web, we do cut and we do repair with the doubler over the area. And we have to calculate all the load loss. That one I have shown to you on the previous lesson. You should be able to understand this, how to calculate the resultant forces loss due to the cutout, and also what are the forces you recover by installing the doubler. And last one is infinite skin. We can say this skin is similar to what we have on the aircraft fuselage. So we consider this infinite skin. So we have damage, we have cut, we put a doubler over it to restore the load carrying capability of that skin in this area.